Hi everyone, this is Dr. K. Kannan, Associate Professor, Department of EC, RMK College of Engineering and Technology. In this lecture video, I am going to talk about optical detector noise. Or we can say that photo detector noise. Look at the diagram. So in this diagram shows the optical receiver structure. So in this optical receiver, consider optical detection in terms of photodiode, so that it is called photo detection, then detector. Then finally we can improve the gain by using electronic gain device. Now look at that, the input to the photo detection is optical signal. So the noise which is added in the photo detector, it is a quantum noise, dark noise, background noise, it bit from incoherent carrier. And second one, avalanche gain for APD, it should be an optional one. So if you are going for APD, then we have excess due to random gain mechanism, and we have detector and load bias where the noise is getting added in terms of thermal noise. Then we have amplifier, the amplifier where we can have thermal input resistance and a device. So this is the general block diagram of the optical receiver. Then photodetector noise. In fiber optic communication system, the photodiode or photodetector is generally required to detect very weak optical signal. Detection of weak optical signal requires that the photodetector and its amplification circuitry be optimized to maintain a given SNR, that is signal to noise ratio. The power signal to noise ratio, also designated by SNR, at the output of an optical receiver is given by signal power by noise power. Signal power from the photocurrent divided by photodetector noise power, which is added with the noise produced by an amplifier. So photodetector noise and signal to noise ratio. So detection of weak optical signal requires that the photodetector and its following amplification circuitry be optimized for a desired signal to noise ratio. It is the noise current which determines the minimum optical power level that can be detected. So this minimum detectable optical power defines the sensitivity of the detector. That is the power optical that generates a photocurrent with the amplitude equal to the that of signal to noise ratio SNR, that is S by N equal to 1. Then look at the diagram. So simple model of photodiode receiver, where we have photodiode receives the optical signal from the optical fiber that is given to amplifier. This should amplify low incoming weak signal. Then this is equivalent circuit, so that the signal to noise ratio is equal to signal power from the photocurrent divided by noise power by the photodetector, that should be added with the noise by amplifier. So detector current is represented by IP. So IP equal to capital IP plus small ip. So where the direct current value is denoted by capital IP and the time varying current with zero mean is denoted by small ip. So therefore, when we take the average, then IP square is equal to limit t, capital T tends to infinity 1 by t, integral from minus t by 2 to plus t by 2 IP square of t dt. Then we have quantum noise. So quantum noise arises due to optical power fluctuation because light is made up of discrete number of photons. So that the average quantum noise, or we can say that it is short noise, it is equal to 2q IP capital B m square f of m. So f of m, it is a noise figure for the avalanche photodiode. IP, it is a mean detected current, and B, it is a bandwidth q equal to charge of an electron. Then we have dark or leakage current. So this current, without any incident light, there is small current will flow. So this is called the dark current, or we can say that leakage current or surface leakage current. Then finally we have thermal noise. The photo detector load resistor RL contributes to the noise is called the thermal noise, or we can say another name is called the Johnson noise. So it can be represented by T. So IT square is equal to 4 KTB by RL, where KB equal to Boltzmann constant. The value of Boltzmann constant is 1.38054 into 10 power minus 23 joule per Kelvin, and T is absolute temperature. Quantum and thermal noise are the significant noise mechanism in all the optical receiver, and relative intensity noise will also appear in device. Thank you.